Hello, class. This will be the recorded lecture for section 4.3, our college algebra class, and this is going to walk through all the key attributes of a quadratic function. Probably the most important section in chapter 4. And what it does is it lays a foundation for chapter 5, because we're going to do the same thing for more complicated equations. And if you have a good understanding, this is kind of the foundation for quadratic. If we make it x to the third or x to the fourth, et cetera, very similar concepts will be used. And so really important foundation. So we're going to walk through pretty much everything there is to talk about, all the attributes of a quadratic function. So let's get started. Here we go with our definition of a quadratic. And we've talked about this in previous chapters, where we have ax squared plus bx plus c and equals f of x or y with regards to the equation. And the a value cannot be zero. Because if a is zero, the x squared goes away, and then we have a linear function then instead of a quadratic. And the main reason why this is the preferred format for quadratic is the quadratic formula. And we spoke about that quite a bit. And we'll use it a little bit throughout the rest of the year, actually, but definitely in this section. So here we have some definitions. And so quadratic function has what's this idea of degree of a polynomial, which we'll talk about in great detail in chapter 5. The degree of the polynomial is the highest exponent on the x variable. And here we have a 2, so the degree is 2. And the shape of the graph is called a parabola, which is a u. And the vertex, the most important point in the parabola is where the parabola starts. And the good news is we have a nice formula for calculating the vertex, given that it's in its standard form. And the standard form is that the x value of the parabola is, so if you had y equals ax squared plus bx plus c, the x value of the vertex, I'll just call it xb, is minus b over 2a. So again, very useful in this calculation. But then how do we get the y value? Well, given this x value, right, what we do is we plug it back into the equation and out will come the y value. So there is a process. First find the x value and then plug that back in to find the y value. And we'll go through some examples for sure moving forward. But I'd like to continue on some definitions with this kind of form. So there's also something called the vertex form, nowhere near as useful, but it does have its place. For those of you that might be studying optics, for example, the vertex form is quite useful because it gives you what's called the foci. And so if you're designing a lens, kind of important. So we're not going to focus on this class, but if you ever did do some optics, you'll see that they would take these quadratic functions and put them into a more of a vertex form. So here's some more key attributes. First of all, the domain of a quadratic function is all real numbers. No bad number or no real number that you plug in won't give you a real number out. We're not taking the square root. We're not dividing by anything that has an x in it. So everything is cool with that. The range is restricted though, and it really depends on where the vertex is and how the graph is oriented. So again, once I give you a few little more information, you could actually calculate the range of a quadratic without graphing it. So we now know how to do ranges of linear equations without graphing it. It's all real numbers, right? But quadratics you can do without graphing as well. After that, not so easy. So, but here's another really important attribute of a quadratic, the idea of the a value. And what does the a value tell you? It tells you how the quadratic graph, again called a parabola, is oriented. And so what we mean by that is if we had an a value greater than 0, then the parabola ends up opening up. So it looks something like this. And that's what we mean by opening up. If the a value is less than 0, then the parabola would open down. Just an example. So here's the vertex, and that's kind of where it starts. And so one idea here is you want to find that point first when you're starting to do the sketch. And you'll see that when you're answering a bunch of different questions, even in the application section, which is at the end of this lecture, we'll show you how the vertex becomes an important point in answering a bunch of questions. Okay, so let's do a couple quick calculations now with the new information that we have. So here's an equation, y equals x squared plus 6x minus 7. And again, I find it useful to make sure that you have these values, and I'd like to write them out. Whoops, see, because you could see it's easy to make a mistake with a sign. And when you do that, nothing works right. So I always like to write them out. So for me, it's easier to see visually that way. And so let's talk about what we've just introduced to you, this idea of the vertex. And so the x value of the vertex is minus b over 2a. So what would that be? Well, b is 6, so minus b is minus 6. And a is 1, and 2 times 1 is, that's not a b, that's a 6. And so when you do that, you get minus 6 over 2, and that would be minus 3. So this is the x value. So what is the y value of the vertex? Well, we have to plug it in and see what we get. So when you plug that in, you get minus 3 squared plus 6 times minus 3 minus 7. And so when you do that calculation, you could see that this would be 9 minus 18 minus 7. And so when you look at that, this would be minus 9 and minus 7. That would be minus 16. So the vertex is x equals minus 3, y equals minus 16. And so that's typically how you indicate the vertex in the point form. And so when you do some of the homework, you'll see that that's how they're going to be asking the question in my math lab. The other thing that we talked about is the a value is positive, right? So if we sketch this thing, the vertex would be somewhere down here, right? And so when you open this up, it would look like a graph that looks like that. And so I'm going to show you in detail a good approach on sketching a parabola a little bit later, but I just want to point out that because the a value is positive, you can see that the u is pointing up, or the parabola, excuse me, the parabola is pointing up. So while I have this equation up here, it would be good to walk through a nice review of some things that we already know, right? So what was some other things that we talked about? Well, we talked about x-intercepts and y-intercepts, right? Well, the y-intercept is the easy one, right? What is the y-intercept? Well, the y-intercept is when x equals 0, right? And so it's always this constant term here. And so the y-intercept will be x equals 0, y equals minus 7. The x-intercept, that's the challenge. And you'll see when we make the equations even more complicated, it becomes more of a challenge. The y-intercept's always quite easy. And so we could see here that the y value equals 0 for the x-intercept, right? And so we look at it this way. And you could see that I've strategically set this up where this can be factored, 7 and minus 1. So you multiply these together, you get minus 7. You add those together, you get plus 6. And that would equal 0. So the two x-intercepts would be minus 7 and x equals plus 1. And so you typically write them this way sometimes. And that would be 1, 0. So we talked about this again already, but it's definitely worth reviewing. And this is the idea of when you're using the quadratic formula to calculate the x-intercepts. And remember, we had this thing underneath the square root called the discriminant. And so we actually had this same slide when we talked about it in chapter 2, I think, but previous chapters, where if what's underneath the square root is a positive number, which is the first one greater than 0, you're going to get two x-intercepts. And if the number inside is 0 under the square root, you'll get one x-intercept. And if the number is negative, then you can't solve it. And again, remember, let me clear this, that we have minus b plus or minus the square root of b squared minus 4ac all over 2a. So when this is positive, you see the plus or minus gives you two possibilities. When this is 0, plus or minus 0 is still the same number, so you only have one x-intercept, which will end up being the vertex. And we'll show you that in a little bit. And the last thing is when this is negative, then you can't take the square root of a negative number and get a real number out. So then you have no solution or no x-intercepts. So I'm going to stop the recording and, oh, no, I am on. I lied. One last thing I will do, and this one, is to just show you a couple more examples of the a value. And so in this case, here's an example when the a value is positive, you can see that the values, the graph is opening up in U. And here, the a value would be negative, so the graph is opening down. So it's upside down U, or kind of how I think about it. And the other attribute that we're going to introduce, and then I'm going to stop the lecture, is this idea of what's called axis of symmetry and how the vertex relates to what we talked about for relative maxes and mins. So the axis of symmetry is just the vertical line that passes right through the vertex. And you'll see what we mean by symmetry is that if you move 1 point to the right or 1 point to the left of the axis of symmetry, that the y values are going to be the same. And it's very helpful when we do the sketches. And so remember, the axis of symmetry is going to be an equation of a line. And the equation of a vertical line is x equals the vertex. So that's always the axis of symmetry when we do that. And so remember, the axis of symmetry is x equals the x value of the vertex. If you remember the last equation we had x squared minus 6x, or plus 6x minus 7. And we had the x value of the vertex is minus 3. So the axis of symmetry for that particular quadratic is x equals 3. And then the other really cool thing, and this is a very important attribute of a quadratic, is you remember that We talked about relative max and mins. And you see that here's an example of the A value being greater than 0. So it opens up. You can see the vertex is the lowest point. And so remember we said when it's decreasing and then increasing, what ends up happening is you have a relative min. Well, you can see because the quadratic only has 1, it's going to be an absolute min as well. And same when the vertex or the A value is greater or less than 0, excuse me, and the U is pointing down, less than 0, you can see we go increasing, then decreasing. So what ends up happening is the vertex is not only a relative max, it's also the max, the absolute max. And so you'll see that when we do some applications, knowing relative maxes and mins from the quadratic will be a very important attribute. So here's where I'm going to stop. So this ends the first of, I think there's going to be 3 total recorded lectures for section 4.3.